So let's take a look at our last three examples that are on the T and B notes, but really are more along the lines of vector motion. So let's consider the position vector r of t equals 2 sine of t over 2I plus 2 cosine t over 2j. And let's sketch out a path traced. I said that backwards. Let's sketch a path traced out by the r of t. So the easiest way to do this probably would be to, just like when we were dealing with parametric functions, look at a table of values as it relates to t. And I'm going to choose t values that will work out nicely for us. So if we plug in 0, sine of 2, 0, wow, 2 sine of 0 is 0, and 2 cosine of 0 is 2 times 1, which is 2. So if we look at this, we'll start and draw this at 2. There's my first point up on that y-axis. All right, now we know vectors have direction, so let's keep that in mind as we continue to move forward. If I plug in pi, I would get 2 sine of pi over 2, so 2 times 1. And this would give me 0. Hopefully you know what this shape is going to look like. Hopefully you can see that this is going to continue to be circular as it moves around, and my direction is moving this way. Okay, now it does ask us to find the velocity, acceleration, and speed. So we know that velocity is the derivative of position. So for us, that would end up being cosine of t over 2 times, 2 cosine t over 2 times a half, which gives us just cosine of t over 2. And then negative sine of t over 2 would be my r of t, or my r prime of t, my velocity of t. Okay, so my acceleration then of t is going to be the position, the second derivative of the position, or the derivative of the velocity. And so we would get negative 1/2, oops, that was supposed to be a sine, negative 1/2 of sine of t over 2, and negative 1/2 cosine of t over 2. Okay, and speed. Speed, if you remember from physics, is the absolute value of the velocity. So we're going to use that velocity vector and find the absolute value, or the magnitude of that. And so if I find the magnitude of the velocity vector, I would have the cosine squared of t over 2 plus the sine squared t over 2, which is really just 1. Okay, so the speed of this particular particle is 1. All right, well, it asks us to sketch out a few v of t and a of t. So I'm going to do those in a different color. We'll do velocity in red. And let's look at what the velocity is when t equals 0. Well, when t equals 0, I would have the cosine of 0, which is 1, and the sine of 0, which is 0. So v of 0, when t is 0, my velocity vector is 1, 0. Well, that probably makes a little bit of sense to us, is our velocity is moving in this direction. So as this circle moves around, or as this particle moves around this circle, it makes sense that right here my velocity is that vector. Well, let's look at another velocity vector just for fun. Let's do let's do pi, that other point. And if we plug pi in, we would get 0 and negative 1. And so my velocity vector would be this vector moving down. Okay, well, what does that look like for acceleration? Let's do acceleration in green. If we do acceleration vector at 0, plugging that in, we get 0, negative 1/2. Okay, well, my acceleration then is this vector that's 0, negative 1/2 here. And if we do the acceleration at pi, same idea, just so we can get a picture of it. it makes sense that my vector is negative 1/2, 0. So negative 1/2, 0 is this vector this way. You can see how those two vectors work together to move the particle along that position. Okay, so hit pause and then try the second example and see how you do. Hopefully you had a chance to try this example. I'm going to go about it much the same way. If I want to sketch a path of this, I would make a table of values. So I'm going to start with 0. Let's do 1, 2. We could keep going if we wanted 3. And if I plug in 0, I get negative 4, 0. Plug in 1, I get negative 3, 1. Plug in 2, I get 0, 2. Plug in 3, I get 5, 3. And if we look at this, let's see, 1, 2, 3, 4. If I look at a sketch of this, I would start at negative 4, 0. Then I'd move negative 3, 1. And then I'd move 0, 2. And then I would move 5, 3. And you can kind of see the shape of this as we move in that direction. Okay, so the velocity is the derivative of the position. We know that by now. So we would get 2t, 1. And if I wanted to, I could go through and it did ask me to find when t is 0 and t is 2. So let's do t of 0. So v of 0 would be 0, 1. Okay, and v of 2 would be 4, 1. Okay, so if we looked at the velocity at those 2 points, when t equals 0, t equals 0 is this point right here, so it would be the vector 0, 1. And when t is 2, which is this vector right here, it is the vector 4, 1. So 1, 2, 3, 4, 1. We have a vector moving in this direction. And you can see the velocity at those points, the velocity vectors. Okay, well, let's keep going. Let's do a of t, which is r double prime of t, which would give us 2, 0. So really, it doesn't matter what our acceleration is. At 0, it's the vector 2, 0. At 2, it's the vector 2, 0. So this acceleration looks like that. So if we consider the speed, we know the speed is the magnitude of the velocity. So the magnitude of the velocity would equal 4t squared plus 1 squared. And so the speed when t equals 0 would be the square root of 1. So the speed, speed has a p, speed of 0. And the speed when t is 2 would be the square root of 4 times 4 plus 1, so the square root of 17. Hopefully you did okay on that. All right, let's look at another example. Okay, so this last one says an object starts at rest from the point 1 to 0. Let's interpret that. If an object starts at rest, it means the velocity at 0, right? So it starts at rest, so the velocity at that point is 0, 0, 0. And then the position then, so r of 0 would be 1, 2, 0. Okay, and moves with an acceleration of a of t equals j plus 2k. And a of t equals j plus 2k. So I am going to rewrite that in vector form. Okay, so now what we're going to do is we need to work at finding the position when t equals 2. So r of 2 is what we're trying to find. So first, what I'm going to do is I'm going to take the antiderivative of the acceleration to get the velocity, and this gives us is the constant, we'll call it C1, comma, let's do t plus C2, and then the integral of 2 would be 2t plus C3. Okay, well, what we know is that this is the representation of the velocity so let's write this. V of t equals C1 t plus C2, and then 2t plus C3. Now, we know that v of 0 is the vector 0, 0, 0, the 0 vector. So what I know is that 0, 0, 0 is equivalent to C1, comma, 0 plus C2, comma, 2 times 0 plus C3, which means that C1, C2, and C3 are 0. So that yields a final vector for the velocity of 0, t, and then 2t. Okay. Now we need to go backwards again because I need to find the position vector. So I'm going to take the antiderivative of this velocity vector, and I'm going to get C1 again. Well, it's different, C1. C1 again, t squared over 2 plus C2, and then t squared plus C3. And what I know is that the position at 0, so r of 0 is the vector 1, 2, 0. So when t is 0, so C1, comma, 0 squared over 2 plus C2, and 0 squared plus C3 need to be that position of 1, 2, 0, which means that we get that C1 is 1, C2 is 2, and C3 is still 0. So my position vector is C1, 1, and then t squared over 2 plus C2, which is 2, and then t squared plus C3, which is 0. So my position vector is this. Now, if I want to find the location or the position of the object after 2 seconds, I would do r of 2, and that gives me 1. 4 over 2 is 2, plus 2 is 4, 4. So my final answer would be 1, 4, 4.